Alright, this video is going to cover notes 14G, which is inverses and systems with 3x3 matrices. So we're going to do the same things that we've been doing with 2x2, but this time with a bigger matrix, a 3x3. So it's going to change the process a little bit. So we're going to find the determinant, the inverse, and then solve systems just like we did with the 2x2s. Alright, to define the determinant of a 3x3 matrix, there's three ways, but I'm really only going to talk about two of them. This first way is just a lot of memorization. You just have to memorize all this and what number is where. So we're not really going to worry about that. Second way that you can find the determinant. What we're going to do is take the matrix, and I'm going to rewrite the first two columns. So here's my original matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Then these first two columns I'm going to rewrite. So I have 1, 4, 7 again, and then 2, 5, 8 repeated. And so what we're going to do is start at the top left, and I'm going to get three diagonals. So there's 1, there's 2, and there's 3. And I'm going to multiply the numbers in a diagonal. So 1 times 5 times 9 would be 45. 2 times 6 times 7 would be 84, and then 3 times 4 times 8 would be 96. So from the top left, I'm going to multiply the numbers in a diagonal, and I'm going to add them together. Then I'm going to go from the bottom this time and get three more diagonals. So 1, 2, 3. And I'm going to do the same thing. I'm going to multiply. So 7 times 5 times 3. But this time I'm going to subtract those numbers. Okay, so I'm going to multiply again, but this time I'm going to subtract. So then 8 times 6 times 1 would be 48. And 9 times 4 times 2 is 72. Okay, so then I'm going to do all of this math here. 45 plus 84 plus 96 minus these three. And I get 0 as the determinant. Okay, so the determinant of this matrix is 0. The second way that we have to find the determinant, I realize that this looks like a bunch of confusing numbers, but let me show you what they're doing. They're taking the first number in the first row, so the number 1. Okay, and then what we would do is cross out the row and the column that that number is in. And what we're left with now is what's called a minor 2x2 matrix. And we're going to find the determinant of this 2x2. So just like you did before. So multiply 9 times 5, which is 45, minus 8 times 6, which is 48. And so then I'm going to multiply 1 times negative 3, because that's the determinant of that minor 2x2 matrix. Then I'm going to take the second number in the first row, so this time 2, and I'm going to subtract. So the middle one is subtract, and you'll see in the formula the last one is add. So again, I'm going to cross out the row that 2 is in and the column that 2 is in. And now I'm going to find the determinant of this 2x2 matrix that is left over, that's not crossed out. So I have 9 times 4, which is 36, minus 7 times 6, which is 42. And so the determinant of that 2x2 is negative 6. And then one more time, we're going to take the third number in the first row, so this time 3. And again, I'm going to cross out the row that 3 is in and the column that 3 is in and find the determinant of this 2x2 that's left over. So 4 times 8 would be 32, minus 7 times 5, which is 35. So this gets multiplied by negative 3. Alright, and when I do that all together, you end up with 0 again, because this is the same matrix that we did the last way. So either way, you get the same answer. It doesn't really matter which method you choose, whatever you are most comfortable and confident with. Alright, so here are two examples. I'll do one each way so that we have another example. So this one I'm going to take and rewrite. So I have 1, 0, 0, 2, negative 4, 3, 3, 1, negative 1, and then I'm going to copy the first two columns again. Alright, so then when I get my diagonals, okay, and so I have 1 times negative 4 times negative 1, which is 4, 2 times 1 times 0, 3 times 0 times 3, and then I have to go the other direction and get these three diagonals. So we have 0 times negative 4 times 3, And again, this time I'm subtracting. 3 times 1 times 1. And negative 1 times 0 times 2, which is 0. So when I add all of these together, all the zeros don't matter, so 4 minus 3 is 1. So the determinant of this matrix is 1. I'm going to do the second example the second way we learned. So the first thing is first number in the first row. Alright, and if I crossed out this row and this column, I would have 3 times 2, which is 6, minus 8, so negative 2. Alright, then I would do minus the second number. And again, if I crossed out that first row and the second column, so I would have 2 times 2, which is 4, minus negative 1 times 8, which is negative 8. So 4 minus negative 8 would be 12. And then the last one is plus the third number. And if I cross out the first row and the third column, here's my minor 2 by 2. So 2 minus negative 3 is 5. And when I add all of this together, negative 2 minus 24 is negative 26, plus 25 would give me negative 1. Okay, so again, doesn't matter if you did this one the first way, you would still get 1 as the answer. If you did this one that way, you would still get negative 1 as the answer. So whatever method you are most confident with. Alright, so that's the determinant, and then we're also going to find the inverse of the 3 by 3. So 5 easy steps. The easy is in quotation marks because each step individually is easy, but the process is sort of lengthy. Okay, so we're going to find the determinant and then the transpose. Then this step, we're going to find the determinant of the minor 2 by 2 matrices, so we'll look at what that looks like. Find the adjugate, and then last step, just like with the 2 by 2s, multiply 1 over the determinant by that matrix that we get. So let's look at an example. Okay, so here's our matrix, 1, 2, 3, 0, 1, 4, 5, 6, 0, and we're going to find the determinant. Okay, they have the work here for finding it the second way that I showed you. You can do it the first way. You should still get 1 as the answer. So 1 is the determinant of this matrix. Alright, in step 2, we're going to find the transpose. So remember, this is when we switch the rows and the columns. So 1, 2, 3 was a row. It becomes a column. So now the numbers go down instead of across. So we take in the original matrix and found the transpose. Alright, then the third step. Alright, here's the one that takes a little bit of time. Find the determinant of each minor 2 by 2 matrix. So we're working with the transpose here. So I'm taking the transpose matrix, and here's how this works. So minor 1, 1 means cross out the first row and the first column, and here's the 2 by 2 that we have left, and they wrote it out. So the 2 by 2 would be 1, 6, 4, 0, and then you're going to find the determinant of that matrix. So 1 times 0 is 0. 4 times 6 is 24. 0 minus 24 is negative 24. Okay, and they repeated that process for all 9 combinations. Okay, so when you look at the numbers here, the first number is the row that was crossed off, and the second number is the column. So if we look at this as an example, minor 2, 1 means cross out the second row and the first column, and then the numbers you have left are 0, 5, 4, 0. Okay, and so you're going to find the determinant of each of those different minor 2 by 2s. All right, the order that these are written in is important. So it has to go in the order that you see it here: 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2. Okay, and then so on. It has to be in that order. Alright, as far as writing out the minor, like I don't care if you write out this part because the determinant is the number that we need. But if you are not a very visual person and have a hard time seeing like what's crossed out and what's left over, then you might want to take this extra step and write it out to make sure that you have the right numbers and are finding the determinant correctly. Okay, so we did those for all 9. Alright, and then what we're going to do is take these determinants, so just these answers, alright, and put them in a 3 by 3 matrix. So right here is that new matrix where we just took the determinants in the order that they're in here and put them in a matrix. Okay, and then we're going to find what's called the adjugate matrix, and the way we're going to do that is, you can think of it like as multiplying by this. If it's a plus sign, okay, so if it's in negative 24 is in the same spot as this plus sign, then it just stays negative 24. Okay, if it's in the same spot as a minus sign, so negative 18 is in the same spot as a minus sign, then you change the sign. Okay, so I've had students rewrite this as like if it's a plus sign, you're multiplying by 1. If it's a minus sign, you're multiplying by -1, because that would change the sign. I've also had students rewrite this with K's and C's, so keep the sign, change the sign, keep the sign. Change the sign, keep the sign, change the sign. Okay, so however you need to think of it so that you'll remember, but what's important is it does not mean that if it's a plus sign, you make the number positive. Okay, it does not mean if it's a minus sign, you make the number negative. All it means is if it's a plus sign, keep the number that's there. So -5 stays -5. Okay, but if it's a minus sign, we're going to change it. So -4 is going to change to +4. Okay, and so this right here is what we call the adjugate matrix. And the last step is we're just going to take the adjugate and multiply it by 1 over the determinant. So in this case, the determinant was 1. So if I multiply everything by 1, it stays exactly the same. All right. So those were our 5 easy steps for finding the inverse of a matrix. So now let's go through another example. All right, so step 1 was to find the determinant. Okay, so if I'm going to find the determinant, I'm going to use this method. So -4 times, cross those out, and so I would have 12 minus 5, which is 7. All right, and then the second one is minus. So if I cross the first row, second column, I would have -3 minus 3, which is -6. And then the last one, 0 times, cross out first row, third column, -5 minus 12 would be -17. All right, so I would have -28 plus 24 plus 0, which is equal to -4. All right, so that was step 1, find the determinant. Step 2 is to transpose. So I'm going to take this and switch the rows and columns. All right. Switch the rows and columns. All right, now I have my transpose, so I can start working on all of the minors. So minor 1, 1 means cross out the first row and the first column. So I'm left with this, and then I need to find the determinant. So 12 minus 5 is 7. All right, then minor 2, 1 means cross out the second row and the first column. So now I have -3, -3 minus 3, which is -6. And then 3, 1 means cross out the third row and the first column. So I have -5 minus 12, which is -17. Then I'm going to go to 1, 2, which means cross out first row, second column. So I have 4 times -3, which is -12. Minus 0. All right, 2, 2 means second row, second column. So now I have 12 minus 0. And 3, 2 means third row, second column. So I have 20 minus -12, which is 32. All right, minor 1, 3 means cross out the first row and the third column. -4 minus 0 is -4. 2, 3 means second row, third column, so now I have 4 minus 0. And 3, 3 means third row, third column, so this one is 16 minus 4, which is 12. Okay, so now I'm going to take these numbers and put them in a matrix. So 7, -12, -4, -6, 12, 4, -17, 32, 12, and then I'm going to do the plus minus plus part. So plus means keep, change, keep. Then the second row is change, keep, change. Third row is keep, change, keep. All right, so there's my adjugate matrix, and I need to multiply it by 1 over the determinant. So times -1/4, because my determinant was -4. Okay, and I'm just going to multiply every number times negative 1/4. So negative 1/4 times 7 would be negative 7/4, times 12 would be negative 3, times negative 4 would be 1, negative 1/4 times 6 would be negative 3/2, times 12 is negative 3, times negative 4 is 1, times negative 17 is 17/4, times negative 32 is 8, and times 12 is negative 3. And so that resulting matrix is the inverse. So this is a negative 1. Okay, then we're going to use that process to solve a system. So this time we have 3 equations, 3 variables, so we're going to end up with a 3×3 matrix. Okay, just like you did with the 2×2s, you make one matrix that is the coefficients. Okay, so just coefficients of x, coefficients of y, coefficients of z. Then one matrix that is the variables. And it's equal to a matrix that is the constants. Okay, and we're going to solve this just like we did the 2×2. So we're going to find the inverse of the left side. Once you find the inverse, you're going to multiply it by the right side, and you'll end up with a 3×1 matrix, which is the values of x, y, and z. Okay, so we're going to take that process that we just did, the 5 easy steps, finding the inverse, and then add one more step, which is multiplying by this matrix. So step 1 to finding the inverse is finding the determinant. So I'm going to do that here. So first number times. I would cross out first row, first column, so it would be 72 minus 28, which is 44. Alright, then the second number, remember, is minus, so minus negative 5. I'm just going to go ahead and write that as plus 5 times. If I cross out first row, second column, I would have negative 27 minus 35, which is negative 62. And then the last one is plus 2 times, if I cross out first row, third column, negative 12 minus 40, which is negative 52. So I get, as a determinant, negative 150. Alright, step 2 of finding the inverse was transpose, so I'm going to take this matrix and switch the rows and columns. Alright, so switch the way that these are written. And then I need to find the determinant of all the minors. So 1, 1, cross out first row, first column. I get 72 minus 28, which is 44. 2, 1 means cross out second row, first column. So I have negative 27 minus 35, which is negative 62. 3, 1 means cross out third row, first column. So I have negative 12 minus 40, which is negative 52. Alright, 1, 2 means cross out the first row, second column. Okay, so this time I have negative 45 minus 8, which is negative 53. 2, 2 means second row, second column. So I have 6 times 9, 54 minus 10, which is 44. And then 3, 2 means third row, second column. So this time it's 24 minus negative 25, which would give me 49. Alright, last set here, 1, 3, first row, third column. So I have negative 35 minus 16, which is negative 51. 2, 3 means cross out second row, third column. So I have 42 minus negative 6, which is 48. And 3, 3 means third row, third column. So I have 48 minus 15, which is 33. Alright, so now I'm going to take these numbers and I'm going to go ahead and do the adjugate in one step. So the first row is keep, so keep 44, change negative 53, and keep negative 51. Then it's change, keep, change, and then the third row is keep, change, keep. Alright, and so remember we're multiplying this by 1 over the determinant. So our determinant was negative 150. So I'm going to multiply everything by negative 1 over 150. Okay. Okay, so multiply everything by negative 1 over 150. Now, if you'll notice here, I didn't simplify any of these fractions. I think it's easier to simplify at the end. It's not wrong to simplify here, but I think it's easier to just wait until the very end. Because then I can do this step without a calculator. So I'm just multiplying the first number times negative 1 and then putting it over 150. If you don't do it that way, you're going to be typing a lot more into your calculator because you're going to be multiplying all of these different fractions. So feel free to simplify if you want to, but I think it's easier to simplify at the end because here is our next step. Now we're going to multiply, this is the inverse, so we're going to multiply the inverse times the right side of our original equation, which was this matrix. All right, our constants from the beginning. Alright, and so when we do matrix multiplication, remember it's row times column. And again, I'm not going to simplify here yet either. So I'm going to do negative 44 times negative 1 is 44 over 150. Okay, then negative 53 times 25 is negative 1325, and I'm just going to keep it over 150. Alright, 51 times 31 is 1581 over 150. Alright, then I'm going to do second row times this column, so negative 62 times negative 1 would be 62 over 150. Negative 44 times 25 is negative 1100 over 150. Alright, and then 48 times 31 is 1488 over 150. Then the last row, 52 times negative 1, would be negative 52 over 150. 49 times 25 is 1225 over 150. And negative 33 times 31 is negative 1023 over 150. This is why I choose not to simplify until the end, because now I don't have to type, they all have the same denominator, so I don't have to type these as individual fractions. I can just do 44 minus 1325 plus 1581. So I'm just going to add or subtract the denominators. And when I do that, I get 300 over 150. 300 divided by 150 is 2. Alright, same thing here. 62 minus 1100 plus 1488 is 450 over 150, which is 3. And then negative 52 plus 1225 minus 1023 is 150 over 150, which is 1. So here is my final answer, 2, 3, 1. And remember, just like the 2 by 2s, I'm going to take this and go back to the original equations and plug in those numbers for x, y, and z. So if I plugged in into this equation here, I would plug 2 in for x, 3 in for y, 1 in for z, and hopefully you would get these as the answers. So that's the way to double check yourself. Alright, so that is it for 3 by 3. You have the 5 steps for finding the inverse. Alright, and then if you're solving a system, multiply it by the right side at the end, and you'll get a 3 by 1 matrix, which is your answers.